Hello everyone, welcome back to my channel. In this tutorial, we are going to solve thermomechanical analysis of bellow expansion joint. So I have taken the same bellow expansion joint from the previous case. The material properties are given here. For thermomechanical analysis, first it will solve thermal analysis, then it will take the temperature data from the thermal analysis, and then it will solve the structural analysis. So due to the thermal temperature difference, it is trying to expand. That expansion is arrested by the fixed support. So due to the fixed support, it will generate stress. So here you see the both side here we are fixing in the pipes. So the thermal expansion will be taken by this curved shapes. So inside we are applying both pressure as well as temperature differences. So inside we are applying positive pressure of 7 bar and temperature is inside 400 Kelvin and external temperature is 293 Kelvin and heat transfer coefficient is 25 watt per meter Kelvin. Now we'll do the thermomechanical analysis of bellow expansion joint using Salome. And please subscribe my channel for more videos related to FEA and CFD and click the bell button for notification. Now we'll move to the case. So now I open the Salome. Now we'll take the same file from the previous case. So instead of importing it, so because we have created groups everything in previous case, the same groups we can use it by using the study file. Now just go to the file, open. Just go to the geometry model first. Now check the groups. Fixed group which is necessary to us. Inside we just want to apply the inside temperature as well as the pressure, and outside we just want to apply the external convection. So every groups are available. Now we can use the same groups to apply the boundary conditions. Now just move into the mesh. Meshing also we have already done. So this is our mesh. And all the groups also taken into the mesh. Fixed group we require to fix. Inside we just want to apply the temperature as well as the pressure. Outside convection we just want to specify it. So this also okay. Now just move to the aster study. Just say okay because we have changed the location. Anyway, we are not going to use the previous case setup. Just delete this previous case setup. Now we'll create the setup for thermomechanical analysis. For the thermomechanical analysis, we can create a setup one by one also, step by step procedure by add stage, or we can use the assistant add stage with the assistant also. Now I'm going to use add stage with the assistant using thermomechanical analysis. So just click next. Mesh 1 only, 3D, here conductivity is 45, Young's modulus is 210 gigapascal, Poisson ratio is 0.3 and thermal expansion is 12 e power minus 6. This is, keep it 0. Next, first we can impose the temperature on the groups. So temperature inside temperature is 400 Kelvin. Next, and there is no heat flux, and next there is no volumetric heat source also. Just click it no and next. So initial temperature I'm just specifying it as 293 Kelvin, and thermomechanical said time discretization is not record to me. Just go next. Now we just want to define the mechanical model. So 3D. So impose degree of freedom. We just want to fix the fixed group in all displacements. Just go next. And pressure, we just want to apply it. Inside there is a pressure of 7 bar, 7 e power 5. It's a positive pressure. And only thing is, we are not yet applied this convection boundary condition, because by using assistant we cannot apply convection boundary condition. We just want to edit the setup from the, we just want to apply it. Now everything is finished. Now just save this file. Thermomechanical RMD, just save it. Just finish this file. So just go to the boundary conditions here. So in thermal boundary condition, we just want to add the convection boundary conditions. So here exchange, just edit. So element group is outside convection. Just say OK. And heat transfer coefficient of heat transfer is 25 and external temperature is 293 Kelvin. Just say OK. Now just apply and save OK. So now everything we have specified. The only thing is the structural analysis solver, it will only calculate the displacement. To see the stress value, we just want to calculate by using CalcChamp. Just go to the CalcChamp. Here choose the result meca. Here we just choose sigma elno and sigma nodal, as well as similarly here SAEQ elno and SAEQ node. So equivalent stresses and directional stresses. Just apply. Use the same name. Just apply again. Just say OK. Now in saving results also, we just want to modify it here. Instead of result Salome meca static, we just want to choose CalcChamp. Just say OK. Just apply and OK. Now we have created the setup. The only thing is, we just want to check the setup. We are reading the mesh. This is thermal model and this one is the mechanical model. This is the complete material property. This rho Cp, heat capacity, is not necessary. If you want to remove it, you can remove it also. So only transient analysis, it requires this rho Cp. So just type THER. So isotopic, it will come. Just untick this. Just say OK. Just apply. Here you can see it has removed. And list function, this is also not required. Just delete this one. And load step, first load step, second load, boundary condition and mechanical. And thermal results, this initial condition and time stepping is are not required. Just apply. This initial condition is required for transient only. Just apply and OK. And here, so for the material meca, here we have to check 293 Kelvin. This is the external temperature. Just say OK. Just apply and OK. Now solver, mechanical solver. So loads are correct. Time step is not required. Just apply and OK. So these are modified based on it. Now you can see there is no red color. That means our command is correct. Now we can solve it. We can check the results. Just go to the history view. Just click this plus button. Auto refresh, make it take to 5 seconds. I'm just giving a 4048. Just run this case. Just wait for a while, it will get solved. So after solved, after the result, after the case is solved, we can check the result by using paraview. Now you can see it is solved without any error. The green button is showing. Now message file also we can check it. Diagnostic job is okay. Now we can move into the paraviews to do the post processing. Just go to the paraviews. Just open it. Pictures, code aster, bellow thermomechanical. Just choose this result thermomechanical. This is our result file. Just open it. Here you can see thermal result as well as structural results all came. Now we'll check the thermal result first. So this is the thermal profile of bellow expansion joint. So to take the picture, it's better to go with the rainbow, blue to red rainbow. Just close. Edit. Here you can choose 12. Now this is correct. Now we can go with the structural result. Just apply. We'll check the results one by one. This one is the displacement value. Displacement X. Displacement Y. Now we'll change this color into blue to red rainbow. That is better to be with the yes. So this is the displacement in Y direction. This one is the displacement in Z direction. And this one is the displacement in X direction. Similarly, we can check with the directional stresses. So change the color pattern into blue to red rainbow. Make this into 12. Now just go to the sigma X value. This one is the sigma X. And this one is the sigma Y. And this one is the sigma Z. Similarly, we can check this shear stress also. Just check with the Van Wyse stress. This is the Van Wyse stress, and this one is the stress cast stresses. So we can check the Van Wyse stress by slicing also. We are getting stress very high in fixed location. That is because we are constraining it. By avoiding this fixed location, we can check the other stresses. So for that, just locate it here and just go to the filter, search. Here there is an option called extract space selection. Just enter it. So use the element. Just simply select these elements up to this. Just apply. So instead of that, just select only in this location. Just filter, search, extract selection, just enter it, just apply. Now whatever we have selected, that is extracted now. Just go here, auto scale. So this is the way the stress is developing. The range is from 1.7 e power 7 to 6.1 e power 7. We can add this also. Just click it here. We can increase the selection. Cancel it. Right. So in this way we can check the results. So now we have completed thermomechanical analysis of bellow expansion joint using Salome meca. In next tutorial we will see another component. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.